Okay, this is a quick explanation of question 2 from the challenge part of exercise 13G in the Pure 1 textbook. As we read through it, the graph shows a sketch of the part of the curve C with equation y equals x brackets x minus 1 x plus 2. The curve C crosses x-axis at the origin 0 and at point B. The shaded areas above and below the x-axis are equal. A. Show that the x-coordinate of A satisfies the equation. And B, hence find the exact coordinates of A and interpret geometrically and the other roots of this equation. Okay, so I think the first part of this question is the hardest part. We just remind ourselves what the equation is of that function again, C, and a good idea is it's to do with areas, so we're going to be integrating here, aren't we? So it makes sense that we also expand that out and try and re-express it. So this expands out to become x cubed plus 2x squared minus x squared minus 2x. Now, we should also be considering integration as said for this. So if I consider that I'm told that the areas of these 2 points are equal, then the integral of the function between a and 0 must be equal to the negative of the integral of the function between 0 and the point B. The negative because if you remember the area underneath a curve when you integrate is found to be a negative value, so you need to take that into account by taking the negative of that so that it becomes positive, that we know all areas are. Okay, so if I let A be the x-coordinate at the point A, then I'm integrating between A and 0, my function, and I know that's equal to negative between 0 and the point B, and actually I can figure out that point B from how I was given this equation. I know when it intersects the x-axis, y is going to be equal to 0, and so the intersections of this curve are going to be when x is 0, or 1, or negative 2. So in other words, I know that my B is going to have the points 1, 0, seeing as that's the only positive value, so the only possible answer that B could take. So, and putting all that together, there's only one thing I don't know really here. I know that this expression for the integration is going to be equal to this expression for the integration. Just know that it's from some point A, which is my x-coordinate at the point A. So if we resolve those, we get something like this, and then resolving that a little bit further and further, we get to a point here. This all becomes, I think, negative 5/12. So bringing that onto the other side, we're going to get positive 5/12. And then some value of A, negative A for minus A cubed over 3 plus A squared. Now, I don't really like this because I've got 3 out of my 4 terms are a fraction. So looking for a common multiple of these denominators, if I times every value by 12, then I'm going to get nice integer coefficients for each of these. So that's what we're going to do. I also don't really like having a to the power of 4, the highest power negative, so I think it makes sense for us to bring this all onto the other side as well, to just try and make things easier to manipulate later on. So timesing everything by 12 and then moving so that the higher powers are positive, we end up with this expression here. Now, we could carry on doing the rest of this whole problem in terms of A, but if we remind ourselves from the textbook, it's actually asking us to express it with their definition of the x-coordinate of A, which perhaps I should have stuck with, which they've chosen the x-coordinate of A to be called x. I'm not a huge fan of that myself because we've already been given an x when x is our variable, so that's why I chose A. But to be consistent with where the textbook wants us to go, we should probably use x from now on. So writing this in terms of x, excuse me. Let's just go out a little bit. So writing this in terms of x, and perhaps I'll call it a function of x as well. So I've effectively just substituted x instead of a here to be consistent with the question, and called this function f of x. I think this is the most difficult part of the question because it's not entirely clear where to go from here. And in some ways you've got to take a little bit of a leap of faith and say, okay, I'm going to trust that I've done everything right so far. I'm trying to get towards this. So what could I consider? Well, maybe I should consider if x minus 1 is a factor of f of x, then I could consider substituting 1 into this and showing that it equals 0. So let's do that to check our work. If we substitute and we get there it is 0, luckily for us. And so we could actually do some algebraic division for this now and find out what would be left to as a remainder, or as a left to as a factor of this expression here. And doing so, we get 3x cubed plus 7x squared minus 5x minus 5. So now I can write my f of x. So now I can write my f of x as this expression here. And we can actually, if we remember from the textbook, if this is for, we're told this is for x minus 1 squared is actually a factor, so it should be true as well that I can take x minus 1 as a factor out of this factor of the whole function. So that's what we're going to do. Let's just check it is a factor and we've not made any silly mistakes with our algebraic division or anything yet. So if x is equal to 1, we should get, substituting into that over factor, that this will become 0. It does. So then I'm going to do algebraic line division again, and I get that x minus 1 is a factor with no remainder, so that's exactly what we wanted, and we get 3x squared plus 10x plus 5. And hence our f of x is x minus 1 squared brackets 3x squared plus 10x plus 5, which is what the question asked for. Part B asked us to hence find the exact coordinate of A. So we need to solve this equaling 0, don't we? If you remember right back from before we worked our way through all this, we had our function in terms of A equaling 0. We know that this only works when it's equal to 0. It relates back to when we were equating these two, and then we decided to bring this to the other side, so we had it equal to 0. So, knowing that this is equal to 0, we're going to have to solve this. So one solution is quite easy. One solution is that x is equal to 1. That would mean 0 times all of this, which we know is equal to 0. So that's one solution. The other solution is going to come from solving this quadratic, which we could use the quadratic formula or our calculator to get is minus 5 plus root 10 over 3, or minus 5 minus root 10 over 3. And I think it's quite difficult for these two to spot which is going to be the correct solution for where A lies. This one not so bad. So we know that that's not going to be the x coordinate of A, and that's because it's positive, and we can see from the diagram that A is on the negative x-axis. So how about this point here, minus 5 minus root 10 over 3? Well, not entirely obvious how to do this, but if in doubt you could always substitute into the function, and then if you substitute this into the function you get a negative value. So that tells you that this point here is somewhere below the x-axis. It's actually the point where, if I showed you, it's actually the point, perhaps it's somewhere over here somewhere, where the area here would be equal to the area here. So we've not quite got that yet. That leaves us with just one possibility then, and that's the minus 5 plus root 10 over 3. And that was the answer, so the exact coordinates of A were minus 5 plus root 10 over 3, 0. Hope that helps.